Hi everybody, this is just a short little video just to make sure we all understand the type of measurement that we use in biology. Here in America, we grew up with inches and feet and pounds and gallons. Well, most of the world does not use the same measurement system that the United States use. And that became kind of a problem. And so we need to make sure that when we are doing scientific measurement, we're using the correct units. So in science, we use what's called the International System of Measurement, or the SI system. And it's a lot easier than what I'm going to call the American system because it's based on multiples of 10. So for example, 10 millimeters equal 1 centimeter. 10 centimeters, on and on and on. Everything is going to be in groups of 10. Which if you think about the American system, we have 12 inches in a foot, but there's 3 feet in a yard. And there's 5,000 something in a mile. I'm not all up on my American units, to be honest with you. But with the International System of Measurement, everything is done by 10. So it's really easy to figure out measurements like kilometers. How fast are we going? And so when we do science and biology, earth science, physical science, chemistry, physics, everything you're going to be doing will be the SI. So if you have a ruler, that's why you have 2 sets of numbers. One set of number is what I'm going to call the American system. That's like the inches and the feet. While the other side of the ruler is what a lot of people call the metric system. Now, just some common prefixes you're going to see in biology. All these deal with measurement. And when you get into chemistry, physics, earth science, things like that, you'll see these again. But in the case of anytime you see a big K, that stands for kilo. Most of you are familiar with kilograms or kilometers. That's the same thing as saying 1,000 times. So then we have hecto, which the symbol is H. That's not one you're going to see a lot, but when you do see it, it's 100. You then have deca. Now deca can be spelled with a K or a C. And that is abbreviated DA. Again, not one you see a lot, but that one tends to be in groups of 10s. And then when you have deci, which is a big D, that's 1/10. For those of you who don't like fractions, that's 0.1. Centi is big C, that's 1/100th or 0.01. And milli, little m, 1/1000th or 0.001. You'll be dealing with kilos, decis, centis, and millis, mostly in biology. This just gives you an idea of how big things are, just relative sizes and how with detection devices. Anything between 1 meter to different millimeters, we can see with a human eye. Like we can see a human, an apple, a wasp, an ant, and a hair. Anything smaller than that, we have to move into different types of microscopes, which we'll talk about later on. Now, here in America, we always talk about, oh, this is how much I weigh. Well, weight and mass are not the same thing. Mass is the amount of matter in an object. When we talk about mass, we're talking about elements. We're talking about atoms. What makes you up? And so we use grams as our unit of mass. And like I said, mass and weight are not the same thing. Your mass will determine your weight, but what actually gives you your weight is the pull of gravity. So if you think about it, here on Earth, I weigh 140 pounds. But on the moon, I am almost weightless. Well, I didn't change. I still have the same amount of mass, but gravity is pulling on me differently. So therefore, that change in the pull of gravity changes my weight, but my mass has not changed. Now, most of you have had a bathroom scale or you've gone to the doctors and they've weighed you before. Okay. Well, these are just examples of things called balances. Now, length, again, something that all of you are familiar with. The formal definition of length, people are like, well, if I say how long is length, or how long something is. Okay, well, what does that mean? Well, length is the distance between 2 points. And that's what, in the American system, we talk about feet and inches. Well, we're not going to do that in science. We're going to use the metric system. We're going to use a meter stick. So whenever you have what you might have grown up calling a yardstick, sometimes they'll have one group of numbers on one side and the other group of numbers on the other side? Well, one group of numbers is the yard. It's 3 feet to a yard, 12 inches per foot. But if you notice on the other side, it's done in numbers of 10, 20, 30, 40, 50. That's the metric system. And just depending on how long something is, you'll either use a ruler. Most rulers that you can purchase at the store have both the American system with inches and feet and the metric system on the other side. But if something's really long, you're going to need to use a meter stick. We also are going to deal with volume. Now, the formal definition of volume is the amount of space an object occupies. And that's kind of hard for some people to conceptualize. Okay, well, what does that mean? So the best example that I can think of is if I were to take a swimming pool or a bathtub and fill it up so it's so full of water that the water is almost overflowing. And I have that bathtub on top of grates with a huge measuring cup underneath. And so if a person were to get into that tub, water would overflow. And I would collect that water that's overflowed and I can measure how much water came out of the bathtub. And that tells me how much space that person took up in that bathtub. That's what we call volume. Well, you know, there's 3 states of matter: liquids, solids, and gases. And they're all made up of particles. They're made up of atoms. They're made up of elements. So they all have mass. They all take up space. Okay? So you take up space, your chair's taking up space, your computer's taking up space, the dust particle floating around in the air is taking up space. Well, we have to have a way of measuring that. And so just depending on what we're measuring, the units are a little bit different. When we talk about something that's solid, like you, or your laptop, or your car, we use what we call the term cubic meters. And the cubic comes from the fact that we multiply 3 numbers together. With solid units, we measure the length, the width, and the height. So when we look at cubic volume in the case of solid particles, a lot of times you'll see that volume equals length times width times height. Now, it's easy to take something that's solid and measure it. It's not easy to take a liquid and measure it with a ruler. It's not easy to take a gas and measure it with a ruler. So when we talk about these, we have to use something that is different. So in the case of things that are gases or liquids, we use liters. And here in America, most of us are talking about a gallon of milk. Well, when you go, you can get a half gallon. When we talk about cups, we talk about liters, things like that. Well, when we talk about liquids and gases, we measure them in liters. So your measuring cup that you use measures either cups or liters. So just depending on what we're talking about, they're going to be measured differently. So if we're measuring something like a liquid or a gas, we're going to use things like beakers or this thing called a graduated cylinder. And a graduated cylinder is this really long, skinny looking, see if I can draw it. It looks kind of like this. And it's got numbers on it. Okay, it's my really bad drawing of a graduated cylinder. But that's used to measure liquids. Now in science classes, very rarely will you be asked to measure a gas because it's really hard to capture that gas. But you've all used measuring cups before. You dump the water in the measuring cup, or you know, it's the same idea with a beaker or a graduated cylinder. Okay. In the case of things that are solid, we will use rulers or meter sticks. So we will measure the length, the width, and the height. Which leads us to our last thing, temperature, which everybody knows what it means to be hot versus what it means to be cold. And temperature measures how much heat is in an object. And in today's world, we have, you know, those thermometers that you just hold up to your head, or they're digital thermometers. So believe it or not, several people don't know how to read what we call a formal thermometer. Back in the days, this had mercury inside of it, but mercury is an incredibly toxic substance. So now we just kind of use this like little red liquid that's on the inside. you'll notice there's two sides to the numbers. Now, here in the United States, we tend to deal with Fahrenheit. So for example, normal body temperature is 98.6 degrees Fahrenheit. We talk about how freezing point is 32 degrees Fahrenheit. Well, that never really made sense to me, because if something's freezing, that means it has no heat in it. So I never quite understood why we would say the freezing point was 32 degrees Fahrenheit. Well, again, we're going to use the metric system, and the metric system is based on tens. And in the metric system, freezing point is 0 degrees Celsius. Okay. So 0 degrees Celsius is the same thing as 32 degrees Fahrenheit. Okay. But you can see immediately why, to me, this makes more sense. Because 0 means there's no heat. If there's no heat, it's frozen. Well, when you look at a classic thermometer, you will see two sets of numbers. And that first set of numbers, if you'll notice, one goes by 20s and the other tends to go by tens. Well, on the side that goes by 20s, this side here, that is degrees Fahrenheit. The side that goes by the tens, that is in Celsius. So notice, in humans, what we would say was about, looks like 101 degrees Fahrenheit is actually about 38 degrees Celsius on this thermometer. So as we do labs and things like that, we'll be coming back to different types of measurements. You'll be asked to measure out different types of liquids. So you'll use a beaker or a graduated cylinder. You'll be asked to take the temperatures of different things using these traditional thermometers. We're not going to be using digital thermometers and things like that. You'll use these traditional thermometers. You'll be asked to measure things, and sometimes you'll use a ruler because rulers are smaller, and sometimes you'll use a meter stick because they're larger. But when you're using rulers, meter sticks, thermometers, make sure you're looking at the correct size. Same thing is true if you look at your measuring cup at home. Measuring cups, if you'll notice, tend to have numbers on both sides. There's numbers on the front, numbers on the back, and they don't quite line up. Well, the reason for that is because one of them is the, again, what I call the American system with cups. And the other side tends to be the metric system, which deals with liters. So if you take a look at your measuring cups at home, you will see that they are different. Now, one last thing when we look at beakers and measuring cups that I want to point out. And unfortunately, I accidentally just now deleted the slide, but I'm going to draw my graduated cylinder again. I just got a really bad picture of a graduated cylinder. And I'm going to put water in it. Now, with the way that water does something called cohesion and adhesion, if you were to look at a beaker, or you would look at water in a graduated cylinder, or even in a test tube, if you would hold it up at eye level, you'll notice that it looks like it's curved. Well, when you're measuring water, when you're measuring liquids in beakers, test tubes, graduated cylinders, things like that, you always look to see where the bottom of the curve is. So you're going to look to see where that bottom of that curve is, and that's the measurement that you line it up with. So hopefully this makes sense. You get a little bit basic background information on some measurements that we're going to use, because we do, we'll count seeds, we're going to gather data, we're going to draw graphs. And so we just got to make sure that you're using the correct measurements so you gather the correct data so you get the correct results.